Hello everyone, it's August 16th. Look at that. It's 3 easy questions in a row. And this seems to be new too. In Morse code. Okay. A maps, B maps, C maps. The full table of 26 is given below. Given an array of string words, where each word can be written as a concatenation of the Morse code of each letter. Cap can be, and that's C, and that's A, that's B, which is concatenation, Or call such concatenation the transformation of a word. The number of different transformations among all words we have. Oh wow. So Jin and Zen is the same. That's a design issue, right? So what's the actual way in Morse code that can prevent this from happening? Interesting. Actually, I don't know. Morse code prevent duplicates. How do they do that? I didn't say. Eh. Maybe this one. A dot and a dash. D, da, alpha, da, di, di, dit. Well, they call it dit at the end to indicate the ending. Huh. Interesting. Interesting design. Very interesting. Don't teach me this. I want to see how you decipher. This is just okay. Decipher Morse code. What is a rule? Yeah, I think we go back to this one. Let's say we put in Jin, right? They give us this, and Zan. Oh, look, there's a slight difference. they put a they put something in between. What if we do this? Then they don't know what it is. Huh. Interesting. So do they have like white space? Maybe this is a better question. White space Morse code. Maybe we can learn from this one how they decipher. Didn't really say. Let's see Wikipedia. Dit duration is the basic unit of time. The duration of a data is 3 times the duration of the dit. Dit da, dit da. Okay. Each dit or da within an encoder character is followed by a period of a signal absence called a space, equal to the dit duration. So wait, yeah, that's okay. I got it. Got it. The letters of a word are separated by a space of duration equal to 3 dits. And the words are separated by a space equal to 7 dits. Wait, hold on. I don't understand this. Each dit and da within an encoder character is followed by a signal absence. Oh, okay, so d, like that is a 1 dit duration. Letters of a word are separated by a space of 3 dits. Got it. And the words are separated by a space equal to 7 dits. And 214, 49. Okay, now I want to hear Morse code. And they don't have it. Sample Morse code. Okay, let's listen. Interesting. They do have pauses. Okay, so they use pause. Which is, I mean, honestly, it's fine. Pause is fine. But the question itself is very straightforward. There's nothing to really dig too deep. We know what it's asking for. Basically just translate it, that's it. So we just need a set. Okay, so Morse, actually Morse should be like this. Okay, this is Morse, Lord. And then uniques, that's gonna be a set. A word in words, which is need to translate, right? For letter in word, and each letter is going to be found by Morse something, right? And this thing gonna start join this, and we can say set of this for word in words, Actually, join, we need this. Right, and now we just return the length of this. Oh, now we don't even need this. Alright, so the only logic we need to handle is this thing. Now this will be ORed letter. Are they all lowercase letters, right? Yeah, minus 97, I believe. So test. This shall be 2. And this shall be 1. Run it. Okay. Think we have it. Let's submit it. Oh, I've done this before. Ha! What was the solution last time? What was the official solution? Hash. Oh, I think it's exactly the same. Alright, so that's that. Done with this. Alright, let's try this one. Partition. Hold on. Yeah, I'm testing something on the on my work laptop, so it's kind of working two things at the same time. Alright, you're given an integer array and an integer k. You may partition nums into one or more subsequences such that each element in nums appear in exactly one of the subsequences. Subsequence. Such that each element in nums appear in exactly one of the subsequences, or to the minimal number of subsequences needed such that the difference between the maximum and minimum value in each subsequence is at most k. So we want to divide it into basically two groups, right? We want to divide it into two groups. We want to divide them into two groups, and after we divide them into two groups, it can be any order because it's subsequence, and each one appears in exactly one thing. All of them are unique, probably. Oh, I didn't say they're unique. Well, I just say each one appears in exactly one. And we want the subsequence. What if I divide it into just one? How does that work? Oh, in each subsequence, my bad. So if I divide it by 1, this is going to be 5. And we want it to be... what about it by itself? By itself is 0. Okay, I see. Okay. At most k, so it'll be smaller equal to k. Minimum number division. So for this one, we can divide 1, 2, 3, and 5, 6. Okay. This makes perfect sense. So we'll do 2. Yes. And this will do 3. Yes. Okay. That's a good question. How do we think about it? Let's sort it first. Okay. And then we say we want the minimum number of subsequences. Okay. So minimum is 1, right? We have minimum is 1. Maximum is the length. So for the first one, maximum is 5. And I'm trying to think about binary search. So what if we just say in the middle, right? 1 plus 5 divided by 2 is 3. So let's divide it by 3 and then see the minimum we can get. If the minimum is smaller than 2, then we can keep going, right? So we want to find, basically we say we want to divide this into 3 portions. And what do we get? Well, we have 5 numbers, right? So what we know is if there are pairs, because we sort them, so if there are pairs, but it doesn't guarantee what type of numbers are given to us. Good point. So we definitely want consecutives or things, so sorting is definitely something we need to do. And the smallest we can get is always, because after we sort, right? After we sort, the smallest, the best option is always adjacent, right? That's always the best option, is to have adjacent. Because adjacent, the difference is smaller than if you go not adjacent. Well, I mean, but adjacent, there are 2 scenarios. So you can adjacent to the left, adjacent to the right. So that's another choice. But for now, we say we want to get 3. But how do we find where to put, right? So this will be 2. And we don't want this. It should be like this, right? And then we say, hold on. And we want it to be 2, right? So we can find, let's go through the whole thing and look for how the adjacent values differ. So in the first example, we have 1, 1, 2, and then 1, right? So the maximum, it cannot be bigger than that, right? So once we go through this, if we find any adjacent that is larger than my target, then they will never be together. So we'll definitely put a separation in between them, right? Yeah, we can do that. And after we do that, then we recheck. And then right now, we look at this and we say, okay, everyone is smaller or equal to the value we want. So adjacent is the way to go, right? Ooh, hold on. Now we might be able to get even higher. So 2 is the largest, and then we can separate them or we can put them together. We want as few as possible, right? That's what we want. Oh my god, another error. It's the same thing. Now it's WP client's data. Alright, anyway, let's go back to this. So we want to get as few as possible, which means we want to merge as much as we can. Therefore, we say if k is equal to 2, and we have 1, and we have 1, how we want to merge them together, right? That's 2, so we say, okay, we put something here. And now we have a 2, so this one cannot merge with anybody else. So we put a thing here. And then the last one is 1. This will give us 3, which is actually not right because... Oh, hold on. I put this and these two are already broken. So I put this, then these belong to here, and then just 5, 6. Oh, maybe this won't work. So we sorted it, and then we get the difference, all right? And then that will be another array, which is the diff. Right, so the diff will be 1 smaller, which is fine. So then we just check. Wait, check the first. All right, I'm gonna try to see if we can add a second. And try to see if we can add a third. So once we can add as many as we can, once we add them, as many as we can, right? It's like greedy. And does it work? As many as we can. Yeah, because the best option for each word is gonna be either go to the left or go to the right. That's the best option. And if you go to the left, it's not gonna go, then we just go to the right, right? All right, so this one, we have to try this method, and if it does not work, we will have the trial and error. So let me try this. Yeah, so we just add as much as we can. Once we cannot, like if we add one that breaks, then we revert to the previous one and we set a thing, right? So we say add, and then if we add another one that breaks, yeah, now right now we can say we added one we break, right? Therefore, this is that's the first group, right? And the second group will start. So basically, we just skip this. Yeah, skip the one that's going to cause trouble, and then we go to the next one. Okay, let's give this a shot. 4. Alright, so it's 26 minutes now. So what I want to do, because I still have my work, alright, so what do we learn? Nums sorted first, right? And then we want to find the, oh, we might be able to do it along the way. Okay, right? So for I in range 1 to land nums, perfect. Then we say cumulative. We'll call it C equals 0. Let's call this what do we have now? So we just say C plus equal to nums I minus 1 if C is larger than K. If it's equal to K, that's fine. We want to C larger than K. If C is larger than K, then rest plus equal 1. So whatever's the previous one, we will say that's a group. And after that, we reset C, right? And the current one just skip. And we go again. So we are saying this. So I and I minus 1. This one added too big. So these go away. And I will go to the next one. Okay, that makes sense. That makes sense. We'll go to the next one. Okay. And the next one minus, that will be the start. But how can you guarantee this always work? It's the thing. Does it always work? Well, it will work. It will always work. But would it be optimal? Now, I think it will be optimal because, like I said, each value, the optimal version of arrangement is for it to be with the ones immediately bigger or immediately smaller. And this one satisfies this. It's either immediately smaller or immediately bigger. But anyway, we are going to try at least passing these things, and we can throw, yeah, I guess it's random numbers, right? So we can comfortably throw some interesting, not random options, test cases. Always a fun experience doing that. Wait, what the heck? Partition array. Oh, what the heck? It ain't right. Out of course, because at the end they come out, so we have to add +1 plus the last one. All right. So we will have to get some random number, 10 to the 5th. Okay, just get some 10 to the 5th. Random import rand int. All right, num test. Let's do 10 tests. Yeah, actually, I don't need to do that. I can just for this range, let's say 10 tests. Okay, and then for each test, we will do we'll do what? Oh, actually, yeah, let's just do 1. Let's do like 100 in length. How about that? And then rand int from 1 to 0 actually. 10 to the 5th. I'll just do 1000. Okay. This is our 1000 values. Alright, so what's the value? Let's say do 10. How about 10? Let's see if it works. Okay. How about 100? Should be significantly lower in the value. 9. Okay. Okay, how about we do this? Right. We take this 2, 3. See what I'm doing? 4, 5, 6. Actually, let's go like 20, 30, 40, 50, 60, 70, 80, 90. Okay. Okay, I think this is right. If we throw all these at it, it shall be right. Booyah! It is correct. So it is greedy. Like I said, greedy just have to prove that it's correct, right? I think the proof is just the best, because we want the difference to be as small as possible. So the best way we can do is to have a number to be grouped with something just to its left and or something to its right. That's the best scenario, right? So if it cannot be grouped to the left, it must be grouped to the right. Okay, so with that in mind, and then we sorted it, right? So we basically just sorted, we pick different groups in the sorted array. And we want a group, the difference to be as close to k as possible. So we just constantly adding more, adding more, adding more. And if it doesn't fit on the left, it'll fit on the right. So it's always going to be optimal for each number. So each value will be in its optimal position. I think that will be my justification. Of course, we can go here to see how other people think, but this is my solution, which is ON, right? Greedy. So the optimal position for any number is to be grouped with the number immediately to its left or immediately to its right. Thus, sort the original numbers and then slide window it, right? Basically, it's a slide window. I shouldn't say something. Then compute the difference right? The difference of each consecutive parts of the nums, of the sorted nums. Once the once the overall diff of a part exceeds k, that part can be detached and we start over. That's the solution. Sorting greedy. Yeah, most votes. Sort plus greedy. Yes, I think we are on the same page. Oh, look at this. This is almost the same. Almost the same. We don't even have to do this. We just need to track the largest and the smallest. Yeah, because you sorted it. You sorted it, right? Yeah, it makes sense. All right, anyway, so that's that. All right, so we're done with this, and vote for next. I'll deal with this tomorrow. All right, I'll see you guys tomorrow. Adios.